All right, good morning. Hopefully you guys can hear me. You guys just put yes in the chat box. All right, I'm just looking to see if we have everybody here. I don't see Sydney. Is anybody else here? And then Mason, I don't see either. Does anybody see those? Mason or Sydney or Rowan? I don't see him. And Jacob. Oh, here's Sydney. All right. Oh, thank you, Rowan. All right, so I just have Jacob, Mason, and that's it, because Sydney's here. Great. All right, we're gonna go ahead and just talk about yesterday. I know some people did not turn in their homework yesterday. And then also there were some questions. Would you guys like to go over a couple questions together?
Yes, please.
I could also do, if you like, we could do it at the end. That way you guys can work on your homework too. I could save time at the end to go over questions, if that works for everybody. Okay, you'll work, wait till the end? All right, we'll start then. If you guys go ahead and open up your Google Classroom, there should be assignment. Hold on a second, I'll get it.
Mason, Mason.
All right, we're gonna do the notes first. Hopefully I clicked the right one.
Mason needs let in.
Hold on a second. There it goes. All right. All right, we're just doing a quick review of last year. You guys probably did in geometry, you've done it in algebra too, just of trig ratios, and you probably have talked about them this year too. So we're gonna start with that. I need just a reminder, there is homework during class today too. So we're gonna try to go through this fast and also leave time for those questions on the homework. And if we don't get done, if you guys need, I have the afternoon free if you guys want to meet and then just ask me questions, you can too. So, all right. So let's just go over quickly the trig ratios. Reed and Andrews, what do you know about sine?
It's opposite over hypotenuse.
Hold on. What'd you say?
It's opposite over hypotenuse.
Yep. All right, opposite over hypotenuse. Oh. Okay, what do you know about cosine?
Adjacent over hypotenuse.
Yep. And tangent.
Opposite over adjacent.
Let me let these people in. All right. All right. So Ben, cosecant, secant, and cotangent. What do you know about those then? Are you there, Ben?
Oh, yeah, my mic was muted, sorry.
Okay. What do you know?
They're the inverse.
Okay, so what does that mean?
They're like the opposite of sine, cosine, and tangent.
Yep, so you just have to flip them over. All right. Great. All right, so we're just gonna quickly go down here. I think we're gonna skip this example because I want to make sure you guys have time to ask me questions. So, because the next example is basically the same thing, and it'll save you guys some time. So, it says if cosine of the is equal to 3/5. So let's go ahead and draw a right triangle here. And it doesn't matter where you put the angle at. I'm going to put it right here. Think about that. It says 3/5. What is that? Where does that 3 need to go compared to the angle? Where does it need to go?
So it's cosine, so like 3 would be adjacent.
It'd be adjacent to the angle. Yep, you're right. Okay, and then where did you put the 5 at?
It would be the hypotenuse of the triangle.
Right. All right. So Rowan, what would you like to try to find first? We have to find everything on this triangle. What would you like to try to find first?
So we have to find all the other 5 trig ratios. So if you have cosine, you can find secant, just because it's already there.
Right. So what is it?
3/5.
Okay. So secant would it be 3/5?
Oh, 5/3.
Okay.
My bad.
That's okay.
You can also use the Pythagorean theorem to
Right.
find the other side, and then you have everything you need.
All right. So set it up for us. What would that look like?
3 squared plus x squared equals 25, or 5 squared.
That's great. All right. So we got 9x squared, 25. And we're just going to speed this up. X squared equals 16. So x is 4. So we just found this side right here, 4. All right, I'm going to circle what we need. This one we needed. Okay. So I have secant. I have cosine because it was given. Xavier, what do you think we could find next?
The angles.
Okay. How?
Well, let's see.
Hold on. Let's go back a second. We don't have to find the angles on this one. We just need to find the ratio. So hold that thought because we'll do another problem with the angles.
Okay.
What could you find how about this? Find me sine.
Okay. So the sine would be 4/5, right?
Yep. All right. So Xavier, if that's sine, what about, let's do cosecant.
Cosecant would be hypotenuse over opposite.
So what would that be?
5/4.
Great. Okay, there's 2 more answers. I need 2 more. April, how about you give me the last 2, those other 2, or the other 2 we need to find?
So for tangent, it would be 4/3, and cotangent would be 3/4.
Yep. Great. All right. I'm going to go ahead and flip to the next page. This is just a reminder about 45-degree angles and 90-degree angles, some special stuff. And you guys just did unit circles right before I came. So a lot of this should be familiar to you guys. We're not going to spend time there, but you can look over it and just think about it. You can even think about, well, if I did, 1 squared plus 1 squared equals, x squared, I would get the square root of 2. So you can think about that if you want. We're going to skip to 3. Page 3. We already did this up here, so I'm going to go ahead and write it down again. Well, you guys talked about it. You didn't really do it. So is this inverse? So cosecant is the inverse of sine. And then this would be cosine. And this one would be tangent. And this is great to remember when you use the calculator. We are going to go ahead and do these examples right here. I'll tell you right now, the biggest thing you guys are going to forget. Do you guys see right here on this example, there's a degree. There's a degree here. These ones do not have degrees. Make sure you pay attention to that. That affects your calculator with the mode. So go ahead and put in your calculator sine of 17 degrees. Make sure your mode is in degrees. Otherwise, you will not get the right answer. So Cody, what did you get for sine of 17 degrees?
I got, where should I like round it off to?
Hundredths is fine.
Okay, 0.29.
Yes, great job. All right. And let's save some time. We're going to skip down to this one right here. Notice that's cotangent. How would you put cotangent into the calculator, Mason? How would you put cotangent in?
You can't just put like the number that or how it already comes on the calculator. Wouldn't you have to do like 1 over?
Yes, very good. So make sure you do 1 over tangent, okay, of 1.54. Notice this is not in degrees. So what mode do we need to be in then? Cody, what mode would you put it in?
The calculator, would you put it in, hold up, let me look.
I'll give you a hint. I'll give you a choice, either radians or degrees.
Well, we're trying to find degrees.
It
No.
doesn't, you see that there's no degree sign, right?
Yeah, that's why, yeah.
So you need to change it to your mode. Do you remember how to change on your graphic calculator the mode to radians?
Yeah, you click the mode button.
Yep, and then switch over to radians.
Yep.
Okay, and then go ahead and put in your calculator 1 divided by tangent of 1.54. Just be careful, you guys. Reminder, sometimes when you divide on a calculator, if you don't put certain parentheses in, it will not get the right answer. So just be careful with that stuff. What'd you get, Cody?
Just a second, let me type it in real quick. 1 divided by tangent, where is it? 0.03.
Okay, great job. All right, so we got those answers. Okay, and we're just gonna just point this out right here. When it says to solve a triangle, it means to solve it for all sides. And angles. Okay, just quick reminder. I'm going to go ahead and skip this example because I feel like story problems are actually harder, just to save us some time. And we just remember, I'm going to write down if you guys need to want to go over this one later. You do need to find angle A, which is given, so you can get that one easily. Angle B, angle C, which is given. You need to find side B, side A, and side C. And if you look, side C is already given, is 12. So you just need to find what's left. And you can think, I'll give you some hints here quick. Think about triangles 180 degrees. So I know this one's 90, this one's 30, so I can subtract and get the answer for angle B there. And then these, I could use maybe sine of A over 12 and find my answer. I could use cosine of B over 12 to find B. So those are just a quick thing. If we get time and you guys want to go over more, we can. I have no problem with that. We're going to skip to page 4. Actually, I want you to look at these pictures right here. This is just a reminder when you're looking at drawings, think about your eyes, where your eyes are looking. If I'm looking up, it's an elevation. If I'm looking down, it's a depression. So up, elevation, down, depression. It might help you think down, depression, both start with a D. Just a quick note there. All right, we're gonna do example 1 right there. It says a giant redwood tree casts a shadow of 532 feet long. Find the height of the tree at the angle elevation of the sun is 25.7 degrees. So they gave you the picture. The biggest thing is go ahead and make a triangle of it. So I need to think about this shadow to the top of a tree makes a triangle. And if you think about it, there's a right angle right here. So Kale, I want you to look at what you're given in the picture there and in the story. Think about what would you want to, I need to find the height of the tree. So look at the angle and the height of the tree. What is the height compared to the angle? Is it opposite, adjacent, or hypotenuse?
Opposite.
Okay. And then what about the shadow? What is that compared to the angle? Is that opposite, adjacent, or hypotenuse?
Adjacent.
All right, so we have opposite or adjacent. So what trig function should I use?
Tangent.
Yeah, great. All right. So let's just fill it in. What's our angle, Kale?
25.7.
Right. And what's your opposite?
We don't have opposite.
You're
so
right. So let's call it, just to make it easy because the picture's H, let's call it H.
Thanks.
And what's your adjacent?
532.
Great. All right, Kale, how am I going to solve this?
I'm not sure.
That's okay. You guys might remember, sometimes it's easy to think of it as a fraction. Do you guys remember cross multiplying? You guys remember that? Or you could think about, I have to solve for H, and H is being divided by 532. So Kale, what's the opposite of dividing?
Multiplying.
Multiplying. So I'm going to take 532 times my tangent of 25.7 degrees. Make sure your mode is in degrees now, or you will not get the right answer. So Kale, go ahead and take 532 times tangent of 25.7 degrees.
About 256.
Great. And how are you going to do the unit on this? What unit? You might want to think, Kale, units, think about what you're looking for. What were you trying to find?
The height of the tree.
Yep. So what would that be in?
Feet.
Reread your problem. There's a unit there for height. You see that, Kale? I'm pointing it out to you.
Yeah.
What is it?
Feet.
So it's what is it again?
Feet.
Yes, actually, great job. And there's your answer, 256.03 feet. Okay, we are going to go ahead and do, how much time we have? Okay, we will go ahead and do the last one first. And then if we want time, we can come back. But I'm just going to give you guys a just quick point on this one. You have to find the height of the building here. It says from a point on the ground, 500 feet from the base of the building, observer finds the angle of elevation to the top at 24 degrees. And the angle of the elevation to the top of the flagpole is 27. So you have to find the height of both of these. And then if I need to find just the pole, what would I do with those two heights? What do you think you're gonna do with those two heights, Emily?
What to do with the two heights?
What would you do?
Say that again.
If I found the height all the way from here to the top and from the top of here to the building, how would I find the height of the pole?
Subtract them.
Yes, so I just giving you a point just to think about that because you might have a story problem with that. If we get time, I can go over it too, but I just want to make sure you guys have time for questions too. All right, let's go to the last one. 40-foot ladder leans against the building. If the base of the ladder is 6 foot from the base of the building, what is the angle formed by the ladder and the building? So we have to find the angle. So let's look at the angle and look at the 6 foot. Grace, 6 feet there, what is that compared to the angle? Is it opposite, adjacent, or hypotenuse?
Opposite.
Mm-hmm. And then Grace, what's on the 40 feet?
The hypotenuse.
Yeah, so which trig function should we use?
Sine.
Yes. All right. So Jacob, what is our angle?
Isn't it the? Oh.
Do you know your angle, Jacob?
No.
No, so we're just gonna put the unknown in. We do not know it. Do you know what the opposite side is?
What did you say?
What's the opposite side?
Opposite side?
Yep, of the angle, what's your opposite side?
90 degrees? Is that what you're asking?
No, side, not angle. You're looking at side, so I'm looking at the opposite side.
Or 6 feet?
Yep, and what's the hypotenuse then?
40.
Yep, the hypotenuse is always opposite of the right angle. Right here's your right angle, it'd be the opposite. All right, so Jacob, I can put 60 divided by 40 in my calculator. I can find that, but how do I find the sine of the angle of that?
I did not hear what you said.
Do you know how to find the angle once you know the fraction?
No.
Okay, that's okay. You need to find the inverse. So what you're gonna do is put in your calculator, should be like an inverse button. Do you remember that?
Yeah, it's one with the -1.
Yep, and you're gonna do the inverse of the fraction. Okay, go ahead and put that in your calculator and see what you get. And remember, your mode needs to be in degrees or you won't get the answer right.
Uh, 8.62.
Yep.
8.62.
Yep, and this is an angle, so we need to make sure it's 8.62 what? Degrees, excellent. All right, here's what you guys are do. You have 20 minutes left of class. You have a Delta math assignment that needs to be done by the end of the class. So you want to click on that, get there, get that done. And then I want to stay on. So if you want to ask questions from your homework, or from today, you want to go over that problem, I can do that. There is also homework tonight. If you continue on this page, or not on this page, it's the other assignment. There is a, let me see if I can show you what it looks like. It looks like this, partner paper. You're going to work through that. So that's homework tonight. So you're going to get on and do Delta Math right now. I will stay on. You can mute me if you want, if you're still working on Delta Math, so I don't interrupt you. And if you have questions after you're done with Delta Math, you can ask me as much as you want. Okay? So just stay on, get your Delta Math done, and then ask questions. Colette, I just want to make sure you know that we are working on Delta math right now.
Do we need to submit work for the Delta Math?
No, you do not.
Okay, thank you.
Mhm. Looks like some of you guys are already done and you're not doing great. So why don't you ask some questions? Over, you could do homework, you could do over the notes if you want that a problem. You could even do homework for tonight. Rowan, do you have any questions?
I'm good. Sometimes it just takes me a few tries to get it down.
Okay. If you want to work through a problem, let me know. We can do that.
All right.
Andrew, do you want any help?
No, I'm good.
No questions from last night or even the homework for today?
No, I'm good for today.
Okay. Kennedy, what about you?
I'm okay, thank you.
Reed Patterson, you want any help?
Nope.
Are we allowed to log off when we finish the Delta math?
No, you just need to work on it while you're in here. And then that way, if you need help, I can help.
But I just finished the Delta math.
Oh, then you can stay, just stay on and work on your homework. You can silently if you want. Just
Okay.
go over a couple of problems if you, all right, I put up here, if those of you who are done and would like some help on their homework, I have it pulled up. Amy, if Amy wants to pick which one we do together, we can. 1 through 5, which one would you like to get done? Those of you done, you can pick one, we can get it done.
4.
All right, I'll just pick one then. Let's do number 3. Looks kind of difficult. It says a meteorologist measures the angle of depression. So depression means it's going down of a weather balloon is 53. A radio signal from the balloon indicates that it's 1,680 feet up from his receiver. How high is the weather balloon from the ground? So it looks like this is our height. Oh no, sorry, we need to find how high. So we do not know the height, that's H. And it's 1,680 feet from his receiver. So the depression, if we're looking down is 53. So you might have to think, what do you know about parallel lines? This line and the one on the bottom, they're parallel. So that means this angle would be 53 degrees. Okay. So if I look at 53 and I look at H and I look at 1,680 feet, what do I know about those? Look at H and look at the angle.
H is opposite and
Yeah, it's opposite. What else do you know?
1,680 is adjacent.
Yeah, so what trig function would you use?
Tan.
Yep. All right, and so in order to solve for H, you are gonna have to, the H is getting divided, so we do the opposite, we have to multiply. And if we look at the answer, make sure your mode is in degrees. The answer is 2,229.44 watts. It looks like it's in feet. And there you go. All right, do you guys want, you can pick the next one instead of me picking it if you want to pick the worst one.
We do 4.
Yep. A blimp is flying to cover a football game. The pilot sights the stadium at 8-degree angle of depression. So depression means it's going down. The blimp is flying at an altitude of 420 meters. How many meters is the blimp from the stadium? So we know the altitude, the height is 420. And we saw the word depression, so that's going down. Okay, 8 degrees. So think about parallel lines. If this is 8 degrees, what's this angle right here? It's going to be 8 degrees too. Right, and this is a right angle. And they want to know how far it is from the stadium. So we could call this, you can call it X, is fine. All right, so look at the 8, look at your 420, look at your X, and think what do you know about those sides and what trig function you might want to use.
It's opposite and adjacent, so you want to use
Yeah.
tan.
Yep, tangent, great. Okay, and we're gonna have to multiply across, like cross multiply. So it'd be X times tangent 8 equals 420. This looks really ugly right now because you're like, what do I do with that tangent 8? Just remember between the X and the tangent 8, I don't see a plus sign, I don't see a minus sign, I don't see a division sign. That means they're multiplying right now. So to get rid of the tangent 8, I have to do the opposite. So I'm going to go ahead and take and divide by tangent 8. So X equals 420 divide by tangent 8. Make sure you put this in parentheses. Watch how you put in the calculator. It might not do it right if you don't do parentheses. And don't forget, it needs to be in the mode of degrees right now. And let's see if any of you guys have the answer I have. Anybody get the answer?
I got 2,988.46.
Yep, you got it. What is that? Degrees, meters, feet, what is it?
Meters.
Yep. All right. I'm going to check to see if everybody else got theirs done on Delta Math. Hold on a second. Xavier, are you still there? And Ben?
Yeah.
Don't forget to
Yeah,
do
yeah, I'm
Delta
here.
Math.
Yeah.
Okay. All right. Do you guys want to go over some more problems on that homework? Or if you have homework from yesterday, if they had questions on, you have about 4 minutes left of class. I can even stay on after for a little bit if you guys want.
Could you go over question 10 from the homework on yesterday?
Absolutely. Hold on a second. Let me pull it up.
I just have a quick question. Sorry, I was doing my Delta Math, but for number 3 on this one, like on tonight's homework, is the 1680, is that the longer side of the triangle? Like opposite from the angle?
All right, so we just went over this one. You probably were working on your Delta Math. Let me flip it up quick. You can see the, do you see the, hold on, I need to hit screen share. I think this is Ann that was asking about last night's homework, right, Ann?
Yeah.
Okay, hold on a second. Oh, shoot, I just hit the wrong button.
I mean, you don't have to like pull it up if that's like a trouble or anything.
No, it's okay. I just accidentally hit end screen. All right, so, all right, whoever asked about tonight's homework, do you see on number 3 how I put 1680?
Yeah.
Down here. And see how this is depression is going down, so that's why the angle's there. And then I know because of parallel lines, these two are opposites are equal. They're congruent. So that's why the 53 can go right here.
Okay, gotcha. Thank you
Okay.
so much.
Yep. Now let me try and see if I have enough time. I'll pull up the other homework. Oh, wrong one. All right, and you said number 10, correct?
Yeah.
All right, I think 10's on the last page. Okay, number 10, it says the Earth rotates on this axis every 23 hours and all that time. The biggest thing on this one, do you notice how it says 23 hours, minutes, seconds? Our answer has to be in hours. So this is very time consuming, but we're gonna have to go ahead and convert all this. So I'm gonna start with the 4 seconds. So Anne, you know that 60 seconds are in 1 minute, right?
Yeah.
Okay, so go ahead and take 4 divided by 60 and get that into minutes for me. I'll do it on my calculator too. All right, so I got 0.07 minutes. Now, I have 56 minutes, so I'm gonna add the 56 right in front there to save us some time. And I need to convert that to hours. So 60 minutes. And if you're not in a hurry, I can talk for a little bit longer, okay? The rest of you are free to go. And then put 1 hour on top. So minute cancels. Okay. And you should get 0.93 hours. And if you look right here, there's 23 hours. I'm gonna go ahead and put 23 right in front. So this is my time, right? It's all in hours. Okay, now the biggest thing here is you have to find linear speed. And linear speed is, I just blanked here for a second, S over time. So I don't know S. If you remember, S is theta times R. So I'm going to take my radius right here. Times my theta. So you have to think about this. This Earth is rotating once around every 23 hours and 56 minutes and 4 seconds. So how much does it rotate around?
Like what? Like how do you like degrees or like what?
That's a great question. Now, just keep it simple for now. In that 23 hours, how many times does it rotate around?
Once.
Once. Now I need it in radians. So if it goes around once, what is that as radians?
2 pi.
Yeah. And then you just divide it by your time. Okay. And you should get I kind of went over that pretty quick. So, and if you want, like I can meet you, I don't know if you have time later in the day to go over more questions, I can.
This makes more sense now. I think the hard part for me was like transferring the 23.
Okay, you're cutting out a little bit.
time
Sorry,
into
you're cutting out. I can't hear you.
hours. I think that is where I messed up.
And you cut out a lot. I couldn't hear what you said.
Oh. Can you hear me now?
Yeah, sort of. It's not great, but I can hear you. And how about this? Since you're cutting out, why don't you email me? If you want to go over some stuff, I can totally go over some stuff with it. Oh, I see you typed it. Okay. Do you have any other questions you want to go over? If you do, email me and I can set up a time with you if you just let me know what time you're free. But I have a class right now, so I have to get going. Okay. And Cody, if you have any questions, since you're still on there, let me know too. Thank you, Ann. Yeah, if you have any questions, let me know. And Cody, if you have questions, let me know too. All right, I'll see you later.
All right.